All right, hello AP Chemistry students, Newport High School. So this is the video for Friday's and Monday's lesson, depending on which cohort you're in. And what I want you to do is I want you to try to complete all the lab data using a special focus on significant digits and rounding the final answers to the closest, the correct number of decimals or significant figures. And I'd like you need to show your work on this so I can follow your math and read the directions. You don't have to do every penny that we did in the lab, but here's the lesson for something new. There's this thing called percent error, which you can see I've done behind here. And then the last step is asking you to calculate the percent error of the penny. How close did you get to the real value? Now, error alone is just how close you were. So like if I know the boiling point of water is 212 degrees Fahrenheit, like that's scientifically accepted number, but your thermometer reads it at 209 degrees when you actually put the thermometer in boiling water, then the error is 3. Right? Your error is 3. But percent error is much more valuable, a little bit more complicated to calculate. Why do we use percent error? Because I don't know, let's say your error was 2 centimeters. Is 2 centimeters error a big problem or a small problem? And it's relative. If you're talking about the distance from here to Mars, 2% is not, a big number at all. Or I'm sorry, 2 centimeters is not a big, error at all. But if the dentist is measuring how big the cavity is in your tooth, 2 centimeters is a huge error percentage-wise. So we're going to calculate some percent error throughout the year, starting with today. So here is the formula. I'll try to move out of the way. To calculate percent error, you will take the observed value. This is what you got in the lab. This is your lab calculations, okay? And you will subtract it from the expected, the scientifically expected value, okay? This is just the error. And now I have these absolute symbols here, so it doesn't matter if your observed is a little bit higher than expected or lower. We just want the absolute value of that. You'll take that answer and then divide it by the expected value. And because it's percent, you got to move the decimal or multiply by 100 to get the percent error. So as an example, let's say in the lab, let's do the one we did before. We found that the thermometer said that water boils at 209 degrees Fahrenheit. But we know that the expected value, which we can look up or maybe have it memorized, is 212. You'll take the absolute value of this and divide it by 212. You'll use that expected value again. So I can get a little calculator out since I don't want to do so much. And I take 209 minus 212. I get -3, but I will use +3 divided by 212. And I get an answer of 0.01, but I have not moved the decimal point. So if I multiply by 100, I get 1.41, and that would be about 1.4%. Actually, if this is 3 significant digits and 3 significant digits and 3 significant digits, my final answer should probably have 3 significant digits also. And so a little review of that. So I got 1.42% error on the calculator. So you could double check that. Today for lab, you're going to do the expected value that the government says that a penny should be 2.5% mass by copper. And then you are going to figure out how much we got from our pennies in the class. And I want you to find the percent error of a couple different pennies. Read the directions. Hope this video helps with our lesson. The other thing you can work on, of course, is your CAPA assignment, which is due next week. All right, that's your lesson.